Welcome back, guys. Today I'll be doing CAPE Mathematics Unit 2 question. It is a continuation. I will be doing question 6b. This is a question where I'm going to show that is equal to the following. Let's get started. So I am going to show that the general solution of the differential equation dy over dx is equal to xy minus y over x squared minus 4 is y equal k fourth root of x minus 2 times x plus 2 cubed, where k is a constant. Here I have the differential equation. It is given in the question. It is dy over dx is equal to xy minus y all over x squared minus 4. Now, in the numerator, you can see that I have y being common. Also, you're seeing that I can separate the variables. So that's why I've identified that y is common. I'm going to factor out y. So I have dy over dx. I am going to do separation of variable. Factoring out my y, it means y has been removed. So I'm left with x minus, remove this y, so I'll have 1 in this position, all over x squared minus 4. Now, this is the same as y times x minus 1 over x squared minus 4. So I can rewrite this as a product where it's y times a fraction x minus 1 over x squared minus 4, and it's the same thing as above. Now I need to get the y over to my left by dividing both sides by y. So I divide both sides by y. The y cancel on my right, and division of y means 1 over y. It's the same thing as saying 1 over y. So I have 1 over y dy over dx is equal to x minus 1 over x squared minus 4. Now, I'm carrying the dx over to my right. Separation of variable, putting the y's together, the x together. So 1 over y dy is equal to carrying dx over to my right. So I'll have x minus 1 over x squared minus 4 times dx. Now what's going to happen is that I'm going to integrate both sides. The integral of the left is pretty straightforward. The integral of 1 over y will be ln y because we're integrating with respect to y. On the right hand side, we have x minus 1 over x squared minus 4. So I will have to express it as a partial fraction. So I have x minus 1 over x squared minus 4. Now this is difference of 2 squared. So I can rewrite the denominator as x minus 2 times x plus 2. And next, separating it as two fractions, I will have it as a over x minus 2 plus b over x plus 2. Now, I need to find the LCM of this, and what we're saying is that both sides are the same. So the LCM of x minus 2 and x plus 2 is x squared minus 4, but I can just rewrite x minus 2 times x plus 2. Now, doing division, x minus 2 into the denominator, the x minus 2 cancel, so I'll be left with just x plus 2 times the a in the numerator. to give me a times x plus 2. Next, I will divide x plus 2 into the denominator here. The x plus 2 cancel. So what I'm left with is x minus 2 times the numerator b. So what I will have is b times x minus 2. Now, having this, what it's saying is that this is the same as x minus 1 all over x plus 2 times x minus 2. And since the denominators are now the same, my focus is on the numerator. So I'll be looking at the numerator to find out what is the value of a and what is the value of b. So the numerator, I will have x minus 1, which is the left hand side, is equal to a open bracket x plus 2 plus b open bracket x minus 2. So now I'll be substituting values for x to eliminate a side. So let's look at this. I can replace x to be minus 2 for a times x plus 2 to be gone. So substituting x to be minus 2 in the numerator, I will have minus 2 minus 1 is equal to a. Then I replace here, so it be minus 2 plus 2 plus b, and then x would be replaced, so it will be minus 2 minus 2. So this would be 0, because minus 2 plus 2 is 0, so 0 times a is 0. Minus 2 minus 1, that's negative 3, and minus 2 minus 2, that's minus 4. So I can write minus 4b. Now divide both sides by negative 4. What will be left with is 3 over 4. When we divide both sides, this cancels. And I'll be left with minus 3 over minus 4, which is the same thing as 3 over 4. Now next, I'm going to replace x to be 2 so that I can find out what is a, because 0 will be in that position. So replacing x to be 2, I will have 2 minus 1 is equal to a open bracket 2 plus 2 plus b open bracket 2 minus 2. So we substitute values to eliminate. So this will be cancelled because 2 minus 2 is 0. So what I'll have is 2 minus 1 is 1 and 2 plus 2 is 4. So this is 4a. Then I divide both sides by 4. So this cancels. So a is equal to a quarter. So now I have a to be a quarter and b to be 3 over 4. I can replace letters a and b to be a quarter and 3 over 4. So let's replace. So the partial fractions are a quarter over x minus 2, and some persons would rewrite it as 1 over 4 times x minus 2. That's the same thing. Plus 3/4 over x plus 2. So now to go back to the previous page, now replacing this to be the partial fraction a quarter over x minus 2 plus 3 over 4 over x plus 2, and we're integrating with respect to x. That's what the dx means. So I can just distribute the integral sign. So I will have the integral of a quarter over x minus 2 plus integral of 3/4 over x plus 2, and don't forget my dx. Now I can factor out the fractions. So the fractions can go in front of the integral sign. So I'll have ln y is equal to a quarter integral of 1 over x minus 2 dx plus 3 over 4, and then I'll have the integral of 1 over x plus 2 dx. Now I can go ahead and integrate. So when I integrate 1 over x minus 2, I will have a quarter ln, so this becomes ln x minus 2 plus integral of 1 over x plus 2. I will have 3/4 ln x plus 2, and my constants I'll have plus c. Now, I know when I have numbers in front of ln, I can carry it upwards, so it becomes a power. That's coming from log rules. So I can rewrite this as ln y equal ln x minus 2 raised to the quarter plus ln x plus 2 raised to the 3 over 4 plus c. Now, there's another rule that says when you add to ln or log function, natural log or logarithm function, you multiply. So I can rewrite this as ln x minus 2 a quarter times x plus 2 raised to the 3/4. And don't forget my plus c, don't just disappear. Now, this is the same line that I have on the previous slide. And what I'm going to do is first look at 3/4. I can rewrite 3 over 4 as 3 times a quarter. It's the same thing as 3/4. So 3 over 4 is the same thing as 3 times a quarter. So breaking this down, the power 3 over 4, I will have ln y equal ln x plus 2 all raised to the 3 being the power times a quarter, and then I have the next part, which is x minus 2 raised to the 1 over 4 plus c. Now, the quarter that I have here, which is my main focus, I can factor out the quarter. That's mathematically correct, where I can have x plus 2 raised to the power 3 times a quarter. The quarters I'm going to carry outwards. So what I'll have is x plus 2 raised to the power 3 times x minus 2 raised to the 1 over 4. So the 1 over 4 is on the outside, and it's the same thing. When you multiply, you're getting the 3 over 4 and 1 over 4 here. Now, 1 over 4 is the same thing as the fourth root. So I can have this as the fourth root. So rewriting this, I have ln y is equal to ln fourth root of all of this, which is x plus 2 raised to the 3 times x minus 2 plus c. Now, the ln, it's natural log, and it is the same thing as log base e. So I am going to, where I have the ln y, I'm going to transform it, carry it over to the next side. It's going to become an exponential. Oh, because ln is the same thing as log base e. That's why. Now I am going to carry the ln over to the equal sign. So I will have y is equal to e raised to all of what I have here. So all of what I have on the right will be in a power form. Now from the laws of indices, if I have x to the power 2 plus 3, the indices rule says when you multiply, you add the power. So here I'm moving in the reverse, where I have addition of 2 powers. It can be rewritten as x to the 2 times x to the 3. Laws of indices, multiply, we add the power. So we're going to apply the reverse of this method. So When we add the power, we can rewrite it as multiplication. So it means that I can have y is equal to e raised to the first power times e raised to the second power. It's the same thing. So in other words, I'm saying I can have y is equal to e to the first power. So that's e raised to ln fourth root x plus 2 raised to the 3 times x minus 2, and then I'll have e to the c. Now it's the same thing because indices rule says you write the base ones, which is e, and you add the power, which is what we have up the top. Now I can rewrite this where I have e to the c first. So I'm just rearranging, having e to the c first, and then e to the c is a constant. So I can have e to the c represents k, which is a constant. So in other words, I have y is equal to k, and then here, these cancel, so I will have just 4 roots x plus 2 raised to the 3 times x minus 2. And as you can see, I've proven. That's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below. Next part will be coming next week. Have a great day.